All right, this video is about parametric curves and derivatives. So, if x is a function of t and y is a function of t, and f and g are differentiable on an interval a to b, then the derivative dy dx is simply equal to the derivative of y with respect to t over the derivative of x with respect to t, provided that dx dt does not equal to 0. So, example 1. Find dy dx if x is equal to t e to the t and y is equal to t sine of t. Well, okay, dy dx is going to be equal to the derivative of y with respect to t divided by the derivative of x with respect to t. So what is y prime or dy dx or dy dt? That is going to be 1. So I need to be clear here. I want y prime needs to be, I'm going to call it dy dt. Okay. That's going to be 1. Derivative of sine is cosine plus cosine of t. Okay. 1 plus the cosine of t. All right. dx dt is going to be, we have to use product rule here. First, derivative of second plus second derivative of first is 1. So this is the derivative of x. T e to the t plus e to the t. This is dy dx, example 1. All right, example 2. Find the equation of the tangent line to the curve at the point corresponding to the given value of the parameter. X is square root of t, y is t squared minus 2t, when t is 4. All right. Well, to write the equation of a tangent line, first we have to find the slope of the tangent line, which is the derivative. We have to find dy dx when t is 4. So let us do that. First, what is dy dt? That is simply 2t minus 2. All right. 2t minus 2. What is dx dt? That is 1/2 t to the negative 1/2 over 1/2 t to the negative 1/2. And if we're supposed to evaluate this at 4, that's going to become 2 times 4 minus 2 over 1 over 2 square root 4. This is 8 minus 2 is a 6 over 1 over 2 times 2 is 4. 6 over 1 times 4 over 1. 24. That's my slope. The equation of a line y minus y1 is mx minus x1. We can just throw, this is our slope of the tangent line. What is the point at this? What is x1, y1? Well, when t is 4, x is the square root of 4, which is 2, and y is 4 squared, 16 minus 8. This is my point. So it's simply going to be y minus 8 is 24 times x minus 2. Y is 24x minus 48 plus 8 is minus 40. This is the equation of the tangent line to these curves at t is 4. All right. Example 3. Find the equation of the tangent line to the curve at the point corresponding to the given value of the parameter, where x is t cosine of t, y is t sine of t, and t is pi. What do we do here? All right. First, it's another equation of the tangent line, so we must find the slope of the tangent line. That is, what is dy dx when t is pi? That's what we're after. All right. What's dy dt is going to be, this is another product rule. First times the derivative of the second plus second times derivative of the first. All right. What is dx dt? This is another product rule. It's going to be first times the derivative of the second, derivative of cosine is negative sine, times negative sine t plus second cosine of t times derivative of the first. Now, if we evaluate this when t is pi, this is going to be pi times the cosine of pi plus the sine of pi, or negative pi is what we get here. Negative pi is what all that turns out to be in the numerator. When t is pi, we get negative t, or negative pi, times the sine of pi, which is 0, plus the cosine of pi, which is negative 1. So this ends up being 0 minus 1, or just negative 1. So the slope of the tangent line is pi. What is the point? Okay, the point is when t is pi. So this is going to be pi times the cosine of pi, which is negative 1. So x is negative pi. Y is going to be pi times the sine of pi, which is 0. 0. So let's write our equation. Y minus 0 is equal to the slope, m, times x minus negative pi, or x plus pi. Y is pi x plus pi squared. This is the equation of the tangent line to the curves when t is pi. Okay, example 4. Find the points at which the tangent is horizontal or vertical for these parametric curves. Okay, so when is the tangent line horizontal? Well, that's when the derivative is, when the slope is 0 or the derivative is 0. So when dy dx is equal to 0. Okay. When is the tangent vertical? Well, that happens when the slope is undefined, or when dy dx is undefined. All right, so when will dy dx equal to 0? Well, dy dx is equal to dy dt over dx dt. dy dx will equal 0 when, this is when dy dt is 0. This is when you get your horizontal. When is it undefined? Well, when you're dividing by 0, it's undefined. And so this happens when dx dt is 0. This is when you get the vertical. So vertical tangents happen when dx dt is 0. And the horizontal tangents happen when dy dt is 0. Okay, here we go. So what is dx dt? Dx dt is 3t squared minus 3. Let's set this equal to 0 and solve. So we can factor out a t, leaving us with t squared minus 1. We can factor this into t plus 1 times t minus 1, and we'll find that this happens when t is 1 and t is negative 1. These are the places when we will get a vertical tangent. When t is 1 and negative 1, we get a vertical tangent. All right. Let's try dy dt. Let's take its derivative. So dy dt is 3t squared minus 6t. And if we set that equal to 0, we could factor out a 3t, leaving us with a t minus 2. And we find that this will occur when t is 0 or when t is 2. So we can get the horizontal tangents occur when t is 0 or when t is 2. All right, last example. Find the points at which the tangent is horizontal or vertical for x is sine of t, y is sine of 2t. So we already know horizontal tangents occur when dy dt is 0. So let's start there. Let's find dy dt. And that's equal to the derivative of sine of 2t. So the derivative of sine is cosine. Cosine of 2t, but it's chain rule, so we multiply that by a 2. If we set this equal to 0 and solve, you can divide both sides by 2, get the cosine of 2t is 0. Okay, when will this happen? All right. This will happen when 2t, this angle, is